So starting with this one, there's this reaction. What would increase the yield of methanol? ठीक है. तो यहाँ पे कि so we need more methanol. What that means is we need more forward reaction, right? So without what we're adding a catalyst, that should not. Okay, catalyst जो है वो forward backward speeds up both reactions equally, right? और क्या हो सकता है? If I add more steam to it, what will happen? कौन सा reaction favor होगा?
Backwards.
Backward. It will try to remove steam. Okay, so that means backward will be favored. We don't want the backward reaction to be favored. अच्छा, if I increase the pressure, तो कौन सी side favor होगी? Less gas. कौन सी side है less gas?
Right.
Okay, because you got
Forward.
so you got 2 moles of gas, and on the other side you got 4 moles of gas, right? So forward hoga, so this one is fine. This is nothing wrong with this one. So the answer will be C. Increasing the temperature, what reaction would be favored? The endothermic one. That's definitely not the forward. The forward is exo. The endo is going to be the backward, the opposite reaction. That's going to be endo. So anyway, so next one. Which statement are true about the Haber process in the manufacture of ammonia? So this is what the Haber process is. It's 2NH3. The enthalpy change of the forward reaction is exothermic. That's minus 88. All of them are gases. At higher temperatures, the yield goes down, but the rate of production of ammonia is faster. Is that true? Higher temperature, कौन सा reaction favor होगा higher temperature?
Endothermic. So backwards.
So endo, in this case, it's going to be backward, ठीक है? Your forward is exo, right? So that means the yield goes down, but the rate of, now the next part is about rate. Is the rate going to go up?
Yes.
Okay, that will happen. Both reactions will speed up, the forward and the backward. Higher temperature पे ना kinetic energy ज़्यादा होती है, so both of them they speed up. So that is also true. Rate goes up. So you're getting less ammonia, but you're getting it quickly. Okay, that first statement is true. As a second भी सही हो सकती है. At higher pressures, the yield goes down. Is that true? Yield कम होती है higher pressure पे, कौन सा reaction favor होगा?
Backwards.
The less gas side, right?
Yeah.
And it's going to be the forward reaction, right?
Forward. Forward.
The yield actually goes up, so that one is wrong. Okay, this one is wrong. Production of ammonia is going to be faster at higher pressure because rate of reaction ज़्यादा होगा, but this one is wrong. Presence of a catalyst, the yield goes down. Nothing happens to the yield. Catalyst जो है ना दोनों reaction speed up कर देता है, so nothing really happens to the yield. So this option number 3 is also not really correct. Another question. He's saying, what are possible reasons why the forward reaction is more likely to occur at high temperatures? The forward क्यों होता है high temperature? I mean, in this case, forward is what? Endo, right? So forward is endo. So वो reasons पूछ रहा है. Hydrogen and carbon monoxide do not react at high temperatures. Is that true? They do not. I mean, वैसे सोचो, okay, at high temperatures, do things don't react or do they react at high temperatures? Like just use your.
Sorry,
Remember, they do high temperature करोगे ना तो वो बेशक forward हो backward हो, they have more kinetic energy and there's a higher likely chance of them reacting. They'll more particles will have activation energy. So this statement, do not react higher temperatures में चीजें react करती हैं, ठीक है? So this statement is wrong. As a second one, at lower temperature, the position of the equilibrium lies too far to the left. Is that true? Lower temperature. कौन सा reaction favor होगा? Lower temperature.
exothermic.
And that's going to be backward, right?
Yes.
So that means exo, which is backward, तो ठीक कह रहा है बॉस कि लोअर के ऊपर it's going to lie too far to the left, and the energy of activation is high. So why will the forward reaction more likely to occur at higher temperatures? Because a lot of reactions they need activation energy. So at higher temperatures they'll have the activation energy. So it's more likely to occur. Any reaction is more likely to occur at higher temperatures. Is that clear?
Yes.
So
Yes, sir.
2 or 3 are making sense. The first one is not. I said this one. An increase in acid concentration. So you're increasing H+1. Which reaction will be favored? If you have more H+1, what will it do? It will try to decrease H+1.
जी सर
What's
सर तो सही है
backward?
सर ये इंक्रीज इन H प्लस वो राइट को शिफ्ट कर देगा ना इक्विलिब्रियम को तो
ठीक है वो
पहली
right
और
वो कम करेगा ठीक है so it will increase the concentration of Cr2O7 so the first option is correct in that set uh, so the other ones I mean the catalyst doesn't really it just speeds up both reactions it doesn't change the equilibrium KC अभी हमने पढ़ा ही नहीं है अच्छा which statements are true for the commercial process the temperature see the kind of facts okay if you remember O-level saber process we'll do this later on but उसमें क्या होता था temperature was not 100 it was actually 450 degrees centigrade if you remember that and it's ये वाला ठीक है और the yield of ammonia is very less Haber process में अगर ये तो उसका था अच्छा we've got this reaction what affects the choice of conditions for this reaction uh, a lower temperature would raise the concentration of SO3 is that true would not raise a lower temperature will it raise or will it not raise the concentration of SO3
सर इट विल रेज
तो exo को favor करेगा and the forward one is exo right so not wala part galat hai it will actually raise so that makes option A incorrect it will actually raise the concentration of SO3 a lower temperature of 300 the V2O5 catalyst would not be effective but at a lower temperature is the reaction less likely to occur or more likely to occur at a lower temperature
सर लेस लाइकली
मतलब रिएक्शन होने
Less.
हाँ तो मतलब ये लग रहा है सही है मतलब अभी पक्का नहीं पता लेकिन kind of I mean it's not effective because collisions will not be that energetic and therefore I don't think there's going to be much of a reaction right so तो लग रहा है सही है बाकी दो देख लेते हैं गलत है कि नहीं अच्छा 450 centigrade nitrogen and oxygen from the air combined to form nitrogen oxides which are needed as additional catalyst ये तो खैर वो if you remember contact process uh, this never happened. Nitrogen oxides were not used as catalysts in this case. I said the heat generated by the reaction raises the temperature of the catalyst bed to 600, at which the temperature the reaction begins to take place. So, temperature of the catalyst bed to 600. So, second, what affects the conditions for this reaction? So, तो वो क्या 600 हो जाता है तो अगर उसने खुद ही 600 हो जाना तो why are you giving it 4 I think this one is kind of irrelevant I mean the only thing that makes kind of some sense is okay you're not going to why are you using a lower temperature मतलब इसमें ना justification of conditions में ना there was only one thing that an exothermic process since it's exothermic it requires I mean it's an exothermic process right so it requires a lower temperature for the reaction to happen in the forward direction लेकिन why are we using 450 the reason you're using 450 is कि बहुत low करोगे ना तो the reaction will not be effective so I think the only one that makes sense is option B you can't just lower the temperature too much because the rate of the reaction decreases a lot is that clear
जी सर
Yes, sir.
अच्छा फिर ये कि what is he doing over here he's saying an equilibrium is reached and PCl5 partly. So there's PCl5, this is PCl5, phosphorus pentachloride. Well, and you only have PCl5 initially, and there's an empty gas syringe, which is movable, tightly fitting plunger. The gas is allowed to expand until equilibrium is reached. So gas जो है ना वो decompose कर रही होगी ना, so that's why it's expanding. I mean, you had, let's say, 10 molecules, now you've got 20 molecules because PCl5 will start to decompose. I said the equilibrium, and he's saying that it's allowed to expand, the plunger is allowed to expand until the equilibrium is reached at a temperature at which the phosphorus pentachloride partially dissociates. I said the equilibrium pressure inside the syringe will be greater than the atmospheric pressure. Is that true? कि ये बाहर ना atmosphere plunger के ऊपर ना pressure exert
जी सर.
So this is the atmosphere applying pressure, और अंदर से ना it's the gas that is exerting a pressure. So now remember this, the gas is allowed to expand until equilibrium is reached. So at a temperature at which partially dissociates. Remember, it's a plunger, it's a movable plunger, movable likha hua hai. So once it's at equilibrium, will the plunger move out or in? Once it's at equilibrium, तो gas ज़्यादा बनेगी या कम बनेगी या constant रहेगी? Once an equilibrium is reached.
सर कांस्टेंट रहेगी तो वो प्लंजर मूव नहीं करेगा.
नहीं करेगा, उसका मतलब है the pressure inside जो इस container में and the pressure outside that would become equal because the plunger will stop moving. अगर तो reaction forward जा रहा होगा ना तो there's going to be more gas being produced, right? And more gas will exert more pressure, right? And the plunger will start to move outside, okay, because more gas is being produced. But since it is at equilibrium, that means that more gas produced hona band ho gaya. It's in equilibrium. So the equilibrium pressure inside the syringe will be greater than the atmospheric pressure. That's wrong. क्योंकि जब equilibrium reach हो जाएगा ना, तो it will just become constant and the plunger will stop moving. शुरू में it is moving. Right at the beginning, it is moving. It is expanding until equilibrium is reached. और उसने पूछा भाई ये कि equilibrium पे क्या होगा? तो वो expand करती रहेगी, gas ज़्यादा produce होती रहेगी, and eventually the plunger will stop moving because the net quantity of particles will become constant. तो ये clear idea? Is this clear? पहला वाला कि पहला वाला गलत है? Is this clear?
Yes.
Achha, now he's saying when the plunger is pushed in, the equilibrium adjusts to produce more PCl5. So when you're pushing in the plunger, आप क्या कर रहे हो? Pressure increase कर रहे हो, decrease कर रहे हो?
Increasing, sir.
So what you're doing is you're increasing pressure, right? You increase pressure. Now, since you're increasing pressure, which side will be favored? More gas, less gas?
Less gas.
Less gas.
इसका मतलब it's going to move to the left, right? And it will produce more PCl5. That is true. That makes sense. So the volume of gas in the syringe at equilibrium will be greater than if no dissociation had occurred. So volume of gas will be greater compared to no dissociation. If no dissociation had happened, you'd have less gas, right? But शुरू में तो PCl5 था ना. If it does dissociate, it's going to produce more gas. The volume of the gas in the syringe at equilibrium will be greater. That is true. Compared to no dissociation. Dissociation होगी तो ज़्यादा gas produce होगी. Is that clear?
जी सर.
Yes.
अच्छा फिर अगला कि equilibrium constants, can we ignore that? So this one, you have to figure out whether this reaction is endothermic or exothermic. So he's saying कि 160 के ऊपर ना it's 13% dissociated, and at 300 it's 100% dissociated. So when you increase temperature, which reaction is favored?
And
So that means endo is going to be favored, right? So endothermic reaction is favored, and this case, which reaction is being favored? Forward, right? वो कह रहा है temperature बढ़ा रहे हैं तो there's more dissociation happening, right? So that means the forward one will be the endothermic reaction. The reaction is endothermic. उससे पहले हमने shapes वैसे की थी. PCl3 is pyramidal. It's going to be, the answer will be A. मैं इसको ignore कर देना, endothermic. Is that clear?
जी सर.
अच्छा,
Yes,
so
sir.
okay, so what else? Okay, what would be the consequences of carrying out the reaction at the same temperature but at a pressure of 200 atmospheres? So what is using 60 atmospheres? Now he's saying that you start using 200 atmospheres. So cost to badegi, you'll have a higher cost. Will the yield be higher? Will there be more ethanol produced? Higher pressure.
Yes, sir.
So higher
Oh,
pressure.
no.
Higher pressure. Less gas, right?
Mm-hmm.
Less gas forward, right?
Mm-hmm.
So yield will increase. There's going to be more ethanol, and will the reaction be faster at a higher pressure?
जी सर.
Faster with a higher pressure, it's going to be faster, right? अच्छा बस एक और कर लेते हैं other questions. We'll move on from there. You got which change of conditions will cause the purple color of the equilibrium mixture to become paler? Paler का मतलब है कि where does he want the equilibrium to shift? Forward or backward?
Forward.
ठीक है, वो उसको colorless बनाना चाह रहा है, paler, ठीक है. So he's saying decrease pressure. Will pressure have any effect? Decrease pressure, increase?
sir.
I said it's not going to have any effect because both sides have equal gas moles, right?
जी सर.
So the equilibrium will not shift anywhere. What about decreased temperature, increased temperature? It's an endothermic reaction in the forward direction.
Sir, increased temperature.
Endothermic का
Increase, sir.
increase, right? It's going to be D. So इसके भी देख लेते हैं with theory के interesting questions. यहाँ पे वो what is he saying? He's saying he's talking about this reaction or उसने बताया कि is this endothermic synthesis carried out with a pressure of 40 and using a catalyst, the use of such conditions will both affect the rate of the reaction and equilibrium yield. Explain the effects of higher temperature, higher pressure on the equilibrium yield of methanol. You may have a part missing a question because this is part C. Somewhere above, I think this was given as an exothermic reaction. लेकिन वो सारा आपने explain करना है. Higher pressure क्या होगा? It's going to be forward. ठीक है, it's the same. We did a similar question. Use of a catalyst, no effect because it's going to speed up both reactions equally. So I guess ये क्या आखिरी वाला इसको इग्नोर कर लेते हैं. अच्छा, we'll just move on from here. ठीक है, उसका मतलब बाकी करते हैं कि what is all. This is just low levels. ठीक है, what we just did. थोड़ा बहुत बीच में inorganic आया हुआ था, so we'll do inorganic later on as well. अच्छा, अब ये कि इसे आगे करना है. अच्छा, we know that the equilibrium shifts and it shifts right and left. ठीक है, and now there's a thing called an equilibrium constant. So now we're going to move towards calculations. Okay, so there's a thing called equilibrium constant, and that's known as Kc. I mean, it's got lots of names. Okay, like depending on A levels के अंदर आगे जाके like right now you're going to study Kc and Kp, then you're going to study Ka, then you're going to study Ksp as well, K stability as well. But it's K, it's the same thing, but it's applied to different things. So equilibrium constant. So what is that? And the ones that we're going to study are Kc, and we're going to study Kp as well. So the only difference is that Kc is usually for solutions. C stands for concentration. Okay, the term concentration is mostly used for solutions. So it's mostly related to equilibriums that are in solutions. Gases can be used कर सकते हो concentration, but usually for gases, instead of concentration, what you use is pressure. So this P stands for pressure. The pressure वाली term है that is specifically for gases, because for gases the pressure changes. Solids or liquids के लिए the pressure is kind of invariable. It's लेकिन gases में gas के moles ज़्यादा होंगे तो pressure ज़्यादा होगा. Anyways, let's start from scratch. What is Kc? So we're going to start with Kc. Kp हम बाद में करेंगे. But both of them are kind of the same thing. What happens is that every equilibrium is like this. There's a reactant, you've got a bunch of reactants, and at the same time, you've got a bunch of products. Okay, and there's an equilibrium. Reactants are constantly turning into products, and products are constantly turning into reactants. यानी अगर मेरे पास एक box होगा ना, so in that box, there'll be a bunch of reactant molecules, lots of them, and at the same time, it's going to have a lot of products as well. ठीक है. Or constantly क्या हो रहा है? The reactant is turning into a product. So let's say the green one is the reactant. So that's so this green one, इसको उठाते हैं, it's constantly turning into a product. ठीक है, तो वो red हो रहा है, ठीक है, it's turning into a product. And at the same time, one of the products is turning back into your reactant. तो क्या होता है? Net quantity remains exactly the same. ठीक है, so the quantity of the products and the quantity of the reactants, it kind of remains exactly the same. Is that clear? You look clear now. This basic cheese. Is this clear?
Yes.
Yes.
अच्छा, अब ये कि इसका करना क्या है इस सारी चीज का? So the thing is that the concentration of the reactants and products becomes constant once at equilibrium. But remember, there's a reaction that's constantly happening, except that it's not changing the concentration. So concentration of products and reactants, they remain. So they remain constant. They remain constant. Now, Kc is the ratio. It's the ratio of the concentration of the products divided by the ratio of the concentration of the reactants. इनका ये ratio है. Now, the equilibrium position could be towards the right side, or it could be towards the left side. Okay, it depends. Every equilibrium has a different position. Okay, कुछ products को favor कर, depending on conditions. Some equilibriums will prefer products, some will prefer reactants. यानी आपके container में maybe there's a lot of these green ones. ठीक है, at the end of the day, when equilibrium is reached, so you've got a lot of green particles, right? तो उसका मतलब है कि अच्छा, ये मैंने बताया नहीं है कि green कौन सा है तो वो कौन सा है. The green one is the, let's say, the products, and the red one is the, let's say, that's my reactant particle, right? Whatever they are. So equilibrium किसी भी point पे reach हो सकता है. That you can have, so you can have a lot of these green ones and very few of the red ones. But once it reaches equilibrium, एक दफा equilibrium reach हो गया, the concentration will stop changing. It's not going to change after that. ठीक है? So there's going to be a certain amount of ratio. There's going to be a certain amount of products and there's going to be a certain amount of reactants. In this case, where products कितने हैं? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 products हैं. और reactants कितने हैं? That's 1, 2, 3, 4, right? So ratio क्या बनेगा अगर मैं वैसे ही rough? Let's ignore. It's 10/4 right now, right? And that ratio will be maintained. Because hard time there's a forward reaction, at the same time there's a backward reaction as well. So that ratio will be maintained. The idea clear? Is this clear to everyone? What Kc is?
Yes.
Yes,
Yes,
sir.
sir.
And remember, square brackets is concentration. Okay. So square brackets is concentration. So Kc is a constant and it does not change. Constant का मतलब ये है कि वो constant है. There's only one thing that actually changes है. अच्छा अभी क्या रेशो वैसे इनका है? It's 10/4, right? अगर मैं वैसे रफ रेशो हम obviously concentration ही calculate करें, it's 10/4, right? So that ratio will be maintained. If I try to increase the products, तो where will the equilibrium shift? कि अगर मैं प्रोडक्ट ज्यादा करता हूँ तो इक्विलिब्रियम किस साइड पे शिफ्ट होगा?
Sir, left hand.
So it will try to
To the
increase
reactants, sir.
towards the reactant. So if I try to increase the products, the reactants will automatically increase. So the ratio will still be maintained. Numbers different होंगे लेकिन it will be maintained. अगर मैं product ज़्यादा करता हूँ तो automatically it will shift and it will try to increase the reactant as well. But the ratio is going to be maintained. Is that part clear?
Yes.
Yes.
Yes, sir.
कि अगर मैं वो अच्छा सो मतलब एग्जांपल है कि वो अगर मैं 20 कर देता हूँ मेरे प्रोडक्ट्स तो मेरे रिएक्टेंट्स ऑटोमेटिकली 8 हो जाएंगे ठीक है बट द रेशियो विल स्टिल बी मेंटेन ठीक है इफ आई ट्राई टू इंक्रीज द प्रोडक्ट्स द इक्विलिब्रियम विल शिफ्ट एंड इट विल make some reactants as well and it will try to maintain the ratio is exactly the same so this Kc no matter what you do with the concentration or the pressure it will maintain its value ये सिर्फ एक चीज से चेंज होता है and that is temperature ठीक है Kc is only affected by it's always a constant ठीक है it's always a constant no matter what concentrations and pressures you use that's irrespective of you keep changing that nothing happens to Kc the ratio maintains only affected by temperature तो टेम्परेचर से मसला ये होता है ओनली अफेक्टेड ए वाला है ए एफ ई affected by temperature why temperature because once you increase temperature the reaction all of a sudden goes in one direction or the other direction ठीक है वो रेशियो मेंटेन नहीं रहता फॉर एग्जांपल ये वाटर वाला एग्जांपल है ना कि वो वाटर और प्रोडक्ट्स ओवर रिएक्टेंट्स का जो रेशियो है if I increase temperature then the whole equilibrium will shift to one direction which is that it will form steam it will not no longer form liquid water if I decrease temperature the whole of the equilibrium will shift to the left तो टेम्परेचर से ना रेशियो मेंटेन नहीं होता is that clear
Yes.
That's clear है राफी clear है अब्दुल्ला clear है
Yes, yes, sir.
जी.
अच्छा so temperature is the only thing ये भी याद रखना you get a lot of MCQs so remember it only gets affected by temperature अच्छा now we're going to do an actual reaction so remember it's the concentration of the products divided by the concentration of the reactants how do you actually write the expression so you've got all sorts of equilibriums okay so let's pick an equilibrium and we'll learn how to do two things first one is कि उसका expression and the other one is the unit of Kc calculations बाद में आएंगे units of Kc as an expression in units of Kc so let's say you've got a reaction which is N2 plus CH2 and it's in equilibrium with it's in equilibrium with 2NH3 so that's a reaction and this is my product and these are my reactants it's the ratio of the products to with respect to reactants so Kc will be what's my well it's product concentration divided by reactant concentration right so what do we have we've got NH3 concentration, that's my product. And we've got reactants mein kya hai? We've got N2 and H2. So we've got N2 concentration and we've got H2 concentration. Okay, that's so product over reactants. But there's one thing that the coefficient becomes the exponent. Okay, NH3 ka yahan pe na 2 aa raha hai. So this will become squared. N2 has a coefficient of 1, H2 has a coefficient of 3. So that means it's cubed. वो मैं explain करता हूँ why does that happen? That happens because अगर ये numbers को हटाओ ना, the actual equation is that it's N2 reacting with 3H2s. ठीक है, तो अगर मैं expand करके लिखूँ ना, it's going to be H2 plus another H2 plus another H2, and that's an equilibrium with NH3, two NH3s, right? So it's an equilibrium with two NH3s, right? So जब मैं अपने products देखूंगा ना, तो there are actually two products. There's NH3 and there's another NH3. So it's going to be NH3 concentration. I mean, my products will be NH3 concentration and NH3 concentration. So it will become squared. और मेरे जो reactants होंगे ना, that's going to be, तो मेरे reactants कौन से हैं? I've got 4 reactants actually. I've got N2, I've got another H2, I've got H2, I got H2. So अगर product concentration, reactant concentration करूँगा, it's going to be H2 concentration multiplied by H2 concentration multiplied by H2 concentration, and that will become cubed. ठीक है, तो idea clear है कि the coefficient becomes the power. Product concentration divided by reactant concentration. Is this clear?
जी सर.
Yes.
Yes, sir.
So that's what Kc is. And for any reaction, you're going to write the expression this way. So let's do another reaction. I've got SO2 wala kar lete hain. I've got this reaction which is 2SO2. It's an equilibrium with O2 and so it's और वो equilibrium में किसके साथ है? Equilibrium with equilibrium with 2SO3. ठीक है, so the Kc expression will be product concentration divided by reactant concentration divided by my reactant. अच्छा, my product in this case is SO3. और remember वो या तो इसको SO3 into SO3 कर लो या it's SO3 squared. ठीक है, तो coefficient becomes the power. So that's SO3 and divided by my reactants. What are my reactants? It's SO2 squared and O2 concentration. That's going to be power 1. ठीक है, that's going to be my expression. Or remember ये multiply हो रहे हैं, ठीक है, these are getting multiplied. इधर भी ना, this is getting multiplied. This is not addition. The reactant concentration, that's proportional to all of these concentrations. And product concentration is proportional to NH3 concentration, it's proportional to NH3 concentration, so that's squared. So this is all getting multiplied and divided. तो ये हो गया और एक आध कर लेते हैं. We've got another reaction, let's say इधर आगे कर लेते हैं. So let's say we've got another reaction, and this one is what the reaction? It's so we've got another reaction. I've got H2 plus I2, and it's an equilibrium with 2HI. So इसका Kc expression क्या होगा? It's going to be HI concentration squared, and it's going to be divided by what? It's going to be divided by H2 concentration and I2 concentration. ठीक है, that's the expression. वो एक equation थी वो यहाँ पे worksheet में ना. What will be the Kc expression for this? सारों के लिखना शुरू कर दो. It's going to be NO concentration squared, product, and Cl2 concentration, that's going to be power 1. And the whole thing gets divided by NOCl concentration squared. ये जो value होगी ना, जो भी होगी, that's going to be a constant. You can actually find the value. They've given us the concentration, so you can actually find this value as well. और भी एक आध का कर लेते हैं यहाँ पे. इसका expression क्या होगा? It's going to be Kc product concentration NO2 squared and divide by N2O4. So ये ठीक है, clear है, Rafe, Ahmed?
Yes.
Yes.
I said, now the other thing is, it's one thing is the expression, the other thing is the unit as well, okay? So Kc has a unit as well, and the unit is a physics both. It's how do you find the, every time Kc will have a different unit. ये क्या है? Concentration squared. So I'm going to try and find the unit for this. The unit just a physics में homogeneous equations के साथ करते हो, that you're going to do something similar to that. So how do you find unit? It's mole per dm cube. Concentration unit क्या होता है? It's mole per dm cube, right? So it's going to be mole per dm cube, and that's going to be squared. और फिर bottom के ऊपर ना, there's going to be अच्छा, उसके bottom पे it's going to be N2 concentration, that's mole per dm cube, times multiplied by mole per dm cube, and that's cubed. And this thing is getting cubed. So you're going to simplify this, and you're going to find the unit that way. Okay, what is the unit for Kc? So आपने बस जो भी आपने किया उसके unit use करो and then simplify and find the unit. Now the easier way is कि mole per dm cube को simplify करना, that's kind of tricky. So what you do is just take mole per dm cube as x. Okay, so what I'm going to assume is कि x is mole per dm cube. I'm going to simplify it using x. So मेरा जो unit बनेगा, that's going to be x squared, right? And it's going to get divided by what? It's going to get divided by mole per dm cube, which is x, into mole per dm cube, which is cubed. So ये क्या बन जाएगा? It's going to become x to the power -2, right? And then I'm going to substitute mole per dm cube. So it's going to become mole per dm cube, mole dm -3, and the power is going to be -2. And we can simplify it further. It's going to become mole -2 and dm6. So that is the unit for Kc. पहले दो तीन चीजें वही पूछेगा. They're going to ask you for the expression, and they're going to ask you for the unit. You clear?
Yes.
Oh, sir. So the unit's the same, but only the power is going to change.
Yes, like in physics, like what do you do in physics? How do you figure out the unit? For example, if I want to figure out the unit for acceleration, right? What is that? Change in velocity over time, right? What is velocity? It's meters per second. Change in velocity, that's meters per second. Over time, that's seconds. So what do you get? You get meters per second square, right?
Mm-hmm.
So how do you figure out the unit for force? That's mass into acceleration. So it's going to be kg. Mass is kg, and it's meters per second square, right? So that's how you find units. So over here, since everything is concentration, right? So concentration is mole per dm cube. So you just have, so if you want to find the unit for Kc, so there's no other thing. There's no kg. There's nothing else. It's just concentration squared divided by concentration multiplied by concentration cubed. The easier way, just remember, is take concentration as x, simplify it first, and then substitute what x is. Is that clear?
Okay, sir.
So यहाँ पे what is the unit going to be over here? It's going to be concentration squared. So I'm going to take that as x, and it's going to be divided by so it's going to be divided by concentration squared multiplied by concentration O2, right? This thing gets cancelled out, and it becomes x to the power -1, right? And I can then substitute mole per dm cube. So mole per dm cube -3, and that's the power is -1. So it will eventually become mole -1, and dm will become 3. Is that clear?
Yes,
जी
sir.
सर
तो ठीक है, इसको wrap up करते हैं. ये हमने पहला काम कर लिया. We know how to find or write. We know how to write the value, the unit for Kc. I've told you Kc is always a constant. Only changes with temperature. That's it. Kc is the ratio of the products over reactants. You try to change the concentration. O2 कम करोगे ना तो वो backward shift होगा. O2 दोबारा बढ़ा देगा. ठीक है. It's going to increase O2, right? You try to decrease O2, it will try to increase. It will try to balance out the product over reactants. It's going to try and maintain that ratio, right? So this is the Kc expression. Actually, what does that mean? If you just one last thing, if Kc has a big value, that means you have more products at equilibrium and you've got less reactants at equilibrium. That's why it's got a big value. That means the equilibrium is favoring the products. Is that clear?
जी सर
Yes, sir.
So ये याद रखना कि Kc large indicates that the equilibrium favors the products. And Kc small means that at equilibrium you've got less products or more reactants. So ठीक है, ये कल कंटिन्यू करते हैं इसमें and let's learn more about Kc. ठीक है? Okay, everyone.
ओके सर आप
Sir, tomorrow is there class, sir?
Wednesday we don't have a class.
Oh, so on Thursday, right, sir?
Thursday and Friday. Yeah.
Okay, sir.